Welcome to Ask and Learn.
We're finding the volume of the solid obtained by rotating the region bounded by y squared equals x equals 2y, rotating about the y-axis. So let's first start off by sketching the region. So this is the x and the y-axis. We can first start off by doing the y squared equals x. So the y equals x squared line typically looks like this. But when we take the inverse of that, we basically make it look like this, because no matter what the value of y is, x is always positive. We're basically rotating it by 90 degrees clockwise. And then we can do the x equals 2y line. So normally x equals y looks like this, but we're stretching it out a little bit more, like that. So now we need to find the 2 points of intersection. So the very clear one is 0, 0. And the other one we can solve by equating these two equations together. So we get y squared is equal to 2y. And the very obvious answer here is that y equals 2. Because if y times y is equal to 2 times y, then y has to be 2. And if we plug that in, we get x equals 4. So this point right here, where the two lines intersect, is 4, 2. And we are rotating this all about the y-axis right here. And this is the region that we care about. And so now we need to draw out the typical washer that is created. And so it looks like a washer, a smaller circle subtracted out from a larger circle. So we need to find the cross-sectional area, and that we find in terms of y. Because as y changes, the area changes. The bigger circle is caused by this line right here, because it's always, the x value is always greater, creating the larger circle. So that's x equals 2y. We plug in the x value, because the x value is the radius of the circle. So the big R is just 2y. And so therefore, the small r has to be just y squared. And if we finally simplify all of this, we get that's equal to pi times 4y squared minus y to the fourth. And so that is our cross-sectional area function. We can now go ahead and proceed with our integral. So as I mentioned before, 4, 2 is the point of intersection along with the origin. So we are going from y equals 0 to y equals 2. And we put in the cross-sectional area function that we found before. I'm going to immediately pull out the pi, and then what's left is 4y squared minus y to the fourth dy. And we can find this through anti-differentiation. We said that this is pi. The antiderivative of 4y squared is just 4 times y3, 2 over 3, minus y5 over 5. That's the antiderivative of y to the fourth. That is evaluated at 0 and 2. We can plug this in. We get pi times 4. 2 to the 3 is 8. That over 3. Minus 2 to the fifth is 32 or 16. No, actually it's 32 or 5. We don't care about the case where x equals 0 or y equals 0 because it just gives us 0. And so this is our final answer. We multiply all of this out, and we finally get the answer that this entire integral is equal to 64 pi over 15.